Hello guys. I welcome you all for one more new live stream. Today we are gonna discuss about our Codechef Starters 201 contest, where we are gonna solve almost of 8 questions from Division 1 to Division 4, all the 4 divisions. So Division 4 to Division 1. So yeah. So we'll directly go to our first question. We'll go to our first question, which is selling coins. Chef has A silver coins, B gold coins. Okay, selling coins. Chef has A silver coins, B gold coins. He can avail following two deals: sell one silver coin for rupees 1, trade one gold coin for two silver coin. Chef is trying to sell all his coins and earn money now. How much money will Chef be able to earn? So, first line, only one, first and only line of each test case, it consists of two integers, which is A and B. So there will be two integers in input format, which is A and B, and its range is in between. The range of A and B is between 1 to 10. So both including, and output is what is the amount of money he can earn. So yeah, first thing is now A is our what do you say, the name of the question, selling coins. Okay, what is this? Selling coins. What it says: A silver coins, B gold coins. Okay, one silver coin will cost one. Consider it will cost 1 unit, and he can make two deals. One is okay, two deals: sell silver, sell exchange. He can sell silver. I'm not gonna write everything. He can sell silver for 1 unit, and he can exchange one gold for two silver coins. So his total price is simply gonna be silver into 1 plus gold into 2. That is his total price, basically, in simple terms, if we just write. So there's no need of intuition or anything for this question, I feel personally. I hope everyone are very clear with this question. Simple. Now I'll just quickly write the approach and pseudocode. Approach. Now A, B integers input, int input, and then convert gold to silver, which is 2 into B, add 2 into B to A, which is the number of silver coins he had. Print total money. Print total. That's all. Now pseudocode A comma B input, and next keep it money equal to A plus 2 into B. Print money. So this is the first pseudocode. If we consider the time complexity of this, it is simply gonna be O of 1. It's just 10. 1 to 10 is the numbers integers. So with that, the time complexity is simply O of 1. And also the space complexity, a few integers are used, O of 1. Time and the space complexity. So that's all, I guess. We'll go to our next question, which is, okay, if anyone wanna see the code, here it is. A comma b map int input dot split money equal to a plus 2 into b print money. This is done. Now mixing liquids. Our second question, mixing liquids. Done. We'll see the question quickly. Even this is a simple question. Chef is now making orange juice. He has A units of orange syrup and B units of water. To make orange juice, chef must mix the orange syrup and water in exactly 1:2 ratio. Otherwise, the recipe is spoiled. Further, chef can only use integer amount of liquids because his measuring cylinder cannot accurately measure the fractional quantities. So, chef wants to make as much orange juice as possible. How much will he be able to make? What the total quantity of orange juice is the sum of units of orange syrup and water. So finally you have to give it as the sum of water and orange syrup. Input as number of test cases t, and the second and then the next line consisting two integers a and b. Now for each test case output, what is the maximum quantity of orange juice he can make is our output. So for this the constraints is from 1 to 100 for test cases, including t, which is like including 1 and 100, and then for a comma b it is again from between 1 to 100 including both of them. I'll just take one example. Now yeah, we'll check one example. For it should be in the ratio of 1:2. So if we just see there, if we take an example 1 comma 1 is our orange syrup and water is 4. For this our output is gonna be 1:2. So 1 plus 2 or 2 times of water, which equal to 3. 3 will be our answer for this. Now we'll see the intuition to solve this question quickly. Okay, intuition ratio of 1:2, which means 1 unit syrup, 2 unit water. Done. That's all. So to check syrup availability, we'll put this we'll just create a limiting factor kind of thing. The amount of water we need, is equal to 2 into syrup. And now for water availability, syrup needed is water by 2. That's all. So the maximum syrup we can actually make, it's simply gonna be minimum of a comma b by 2. This is simply our final answer. Maximum syrup, this is our maximum syrup, max syrup we can make, and our final answer is gonna be max syrup, this max syrup into 3. Now approach, what will do? Approach t test cases, and then a and b inputs, and then compute. We have to compute. We'll take a new variable called d is equal to minimum of a comma b by 2, and then we'll take the total juice is equal to, we'll just take in 3 into d, and finally print result, print juice. Okay, fine, I'll write it result. Print result. Done. That's all. Now the time complexity for this is O of 1 for one operation. So for t operation, it is gonna be O of t. Here t is limited between how much? 1 to 100. So the max it's gonna be is O of 100, which we can simply reduce it to O of 1. So here in the given test case it's of O of 1 time complexity, and the space complexity, no for loops used, no loops used, so only a few integer variables we are using. It's just O of 1. Now here is the code itself. I'll show you code itself. Here you have the code. While A will loop through all our test cases, A or T, whatever you want, test cases. B, C is our inputs, and then D is our syrups in our needed ratio, and finally our juice is equal to D into 3, and then we'll just A minus equal to 1, which is A is equal to A minus 1. We are just decrementing A, which is our counter. Is everyone clear with it, guys? I hope everyone is clear with this. So we'll go to our next question. Mark points. Our next question, mark points. There are n equispaced numbers. There are n equispaced points numbered 1, 2 up to n. Initially all points are unmarked. In one operation you can choose x such that x is between 1 and n, and then mark points x minus 1, x plus 1. If any of them is already marked, they do not get affected. Finally, you have to make a binary string S where Si is equal to 1 if and only if marked point is I, otherwise Si. Now you forget what operations you did. You have binary string S with you. You wanna check if it is possible to obtain S by doing some of the above operations of marking points. Print S if it is possible to obtain S, no otherwise. Input format. Each line test cases take. First line will take test cases. In the second line, in each test case there will be two lines or multiple lines of inputs, which is one for N, and the second line is for S, which is our binary string. And we have a boolean output, yes or no, basically output. Now constraints is test cases is like the number of test cases is between 1 and 100 including both. Then number of what do you say, the N value is in between 3 and 100, and then Si is either 0 or 1. I mean Si belongs to 0 or 1, which is a binary string basically. So we'll quickly go to our intuition for this question to understand this. Yeah. What is the name of this question title? Mark points. Mark points. Now, our intuition. In one operation, if we pick X, then 3 points are marked, 3 consecutive points. Then consecutive points are marked. Which is x minus 1, x and x plus 1. It means that whenever we see 1 in the first binary string, for example, if we see 1 in the final binary string, then we for example, take a binary string 111. In this, these ones must have appeared as a part of consecutive blocks, and it should be of at least length 3, which is like 111 or 1111 or 01. And if it is like 011, 1011, this is not gonna be. This will work. This will work. It should be consecutive blocks, least length 3. Of one's block equal to 3. Now we'll take one more case here. 1 This is impossible because only 2 ones. Not possible because 2 ones only are there. And so condition, what will be our condition here? Minimum length equal to, length should be minimum 3, or I will write length should be greater than or equal to 3. Done. Now what we'll do, our approach, in our approach what we'll do is, first we have to call those inputs, IP and all. I won't write that, input and all is taken. In the second point what we'll do, we'll iterate iterate the string. We'll iterate the string, and then what we'll do, we have to track this, we have to count the number. Track consecutive ones. We'll use counter, very easy thing, everyone are aware of it. Now after this, what we'll do, when we get a 0, when we get 0, what we'll do, two cases will come. If previous case, previous block has ones of length 1 or 2, 1 or 2, this is not 1 by 2, 1 or 2, then we'll immediately return no. In this case, what we'll do, we'll immediately return no. In the next case, what is our next case? Otherwise, what we'll do, if not, else, what I'll do, I'll reset the counter. Reset our counter. Okay. Now, after this step is done, what we'll do, we'll go to our next step, our fifth step. Here, after finishing, we'll check for last block of ones. After finishing this, after finish, check also for last block of ones, and then finally, if all blocks length equal to 0 or length greater than or equal to 3, in this case return yes. Return yes. That's all. Now I'll write the pseudo code quickly. Pseudo code will take the test cases input, test cases and other inputs will take first, and after that we'll run a for loop for I in range 1 to n. I hope it's 1 to n. Okay, we'll take it as test cases, not 1 to n. For I in range of test cases, we have to we have to take the input of test cases here. N input we'll take, this is our input, another input, and then S our string input, and then we'll insert a counter. Counter is equal to 0. Now I'll make one more flag is equal to true. There's our validity flag. Now I'll run one more loop for j equal to, okay, for j in range n, range n, if s of I equal to 1. If first digit is 1, we'll first count, we'll increment our counter. Else, we'll put our next condition. In this else condition, there will be two things. If count not equal to 0 and count lesser than 3. In this case, return no. Flag equal to false. We'll just write flag equal to false. If not, and we'll simply break this loop here. Break this loop here, and then initialize count back to 0. Count equal to 0. And then finally, if flag equal to false or count not equal to 0 and count lesser than 3, we'll print no, else yes, else print yes. That's all, guys. Simple. Quickly we'll see the code. That's exactly what I wrote. Count, initialize the counter, and then check for the conditions, if else conditions, and then finally you just have to check for the conditions once more and print yes or no. Next I'll go to no, just a second. So the time complexity of this is gonna be O of n. And for t test cases, it's gonna be O of t into n. And since here it is in here our t is equal to like t is maximum 100, t is greater than or equal to 100, this is efficient, the above solution is efficient, so it will go to O of n into 100 max, which we can reduce into O of n. Now our space complexity. Space complexity here, we are using only a few extra variables for like counter and flag, and also it's just gonna be O of 1. And next question it is, okay, mark points is done, compare and connect. There's a third or fourth question. Compare and connect. Done. Just give me a second, guys. So yeah, compare and connect. If the okay, sign, there's a multiset S containing n plus m string, where n of which are just a second. Sorry guys, there's a multi-set S containing n plus m string, n of which are less than and m of which are greater than symbols. For two strings s and t, function of s comma t is defined as if s is smaller than t in lexicographical order, f of st is equal to s plus, which is the symbol, lesser than plus t, and if s is equal to t in lexicographical order, function of st equal to f s plus equal to plus t, and if s is larger than t in lexicographical order, function of s and t equal to s comma t is equal to s plus greater than plus t. You need to perform n plus m minus 1 operations each time. Choose two strings s and t. In s, insert f of s comma t to s, erase s and t from s. Finally, only one string remains in s. Find the lexicographically smallest possible final string. In lexicographical order, strings are compared based on characters from left to right, and there's about the details where smaller than is or the lesser than is having the least ASCII value, equal to as the middle second and the larger than value is the highest, which is 60, 61 and 62 respectively. How is our input format? Input formatters, first line will have a single integer t, which will take number of test cases. For each test cases, it contains multiple lines of inputs only, and then it will be having two integers n and m. Output will be the lexicographically smallest string possible. Lexicographically dictionary order, basically simple words. Now constraints are test cases are in between 1 and 10 power 4, and n and m are between 0 to 2 into 10 power 5 including both, and n plus m is always greater than or equal to 2, and the sum of digits of n and m overall test cases, it won't exceed 2 into 10 power 5. So we'll go to our intuition about how to solve this question. There'll be three cases, basically three different types. Just a second. There's a third question, and then mixing liquids over. Yeah. Now intuition. What is it? We start with a multi-set S containing n copies of. We'll start with multi-set S having n, thus n copies of lesser than and m copies of greater than. And now what we'll do, we'll repeatedly combine okay, so we'll repeatedly combine the strings based on three functions. Combine using our function f of s comma t, which will be inserting either smaller than or equal to or greater than, and depending upon lexo order. Depending upon the lexicographical order or dictionary order, basically nothing much. Now after n plus m operations, what will happen? N plus m minus 1 operations, only one string will remain. What is our goal? smallest lexicographically smallest lexicographically final string. Yeah. So what are the three like there will be few observations which we need to make here. In ASCII, I'll write it as key observation. What is it? The priorities is like this. Lesser than appears first. I mean, it has the smallest priority. Or we can call, and then not, I'm sorry guys, I'm really sorry. It's not priority. It was the order. And then finally comes the greater than. This is the order in lexicographically this is the order. Now what happens after this? This means more lesser thans are there, the smaller is the final string. Smaller is final string. Yeah. So this is our first key observation, and our second key observation will be if either of n is equal to 0 or m is equal to 0, then we'll combine identical strings only, which means all lesser than results in chain of greater than with exactly one equal to and then all greater than, this will result in chain of mostly the greater than and only one is equal to, but starts with lesser than. Now this is our second observation. Our third observation is if both n greater than 0 and m greater than 0. In this case, what is our best strategy? Best strategy is to put as many smaller thans as possible in the beginning. At beginning. Second one will interleave smaller than with greater than, so that the smaller than won't dominate. Done. Now we'll go to our next condition. Finally we'll end with one extra lesser than. That's all is what we have to do. And what we'll do, we'll greedily construct basically. That's what we'll do. Now approach. I'm showing one approach which I have used. If anyone has any other approaches, you are free to use it, guys. Now, first one, three cases, as I said, three cases. Case 1, what is our case 1? N is equal to 0, which means only lesser than present. In this case, what I'll do, smallest final string starts with and then starts with a lesser than, and then it places greater than and lesser than, and finally it ends with equal to and lesser than. So this is how it's gonna end in our next case. First case done. What is our next case? Case 2, where m is equal to 0. Here what happens? Only greater than present. So smallest oh shit, sorry guys, I just said water. This is when only greater than is present. This is greater than, and then this is only when lesser than is present. When lesser than is present, what will be the case? The smallest final string will be is just a chain of lesser thans, and 1 and 1 is equal to before last lesser than, before the last lesser than, yeah. Finally our case 3, which is n comma m both are greater than 0. Here what we'll do is we'll start with 2n lesser than, and then alternate greater than and less than for m minus 1 times, and finally add 1 greater than, add 1 greater than, and finally this guarantees, so we get lexicographically minimum, lexo smallest. That's all, I guess. Now a pseudocode if I'll first give the time complexity. The time complexity for this is O of n plus m, and we won't be simplifying this. With the test cases, it's gonna be O of sigma of n plus m for all for this is for one test case, one TC, and this is for we'll take t test cases. Sigma is from sigma is still t. No. And then finally space complexity is O of n plus m, because we are using n and m to. This is the length of our string. This is, and since we are avoiding repeated string concatenation and all, our space complexity is O of n plus m. So even this is optimal, and the above time complexity is also optimal. Now I'll come to the pseudocode. No, first we'll import take input and all, and then what you will do, t is equal to int d of 0, I is equal to 1, o is equal to empty array, and then for loop for test cases, and then n m a input you will take, and all those you will do integer input, and thus I plus e increment both of them, and then we'll check for cases, which is if n equal to 0, what we'll do, we'll append greater than, and then we'll run one more for loop, for x in range. I'll take for this, for x in range of m minus 2, what I'll do, I'll append lesser than, and then append smaller than, and then out of this I'll again append, out of this loop I'll again append equal to, and I'll append lesser than. This is case 1. Now case 2. Else if, elif, whatever it is, m equal to 0, a dot, or I'll simply write append lesser than, how many times will append, 2 into n minus 3 times, and then append finally, like the last two, append z equal to, and finally append smaller than, and case 3 finally. Case 3, this is case 3. Here else will extend this, extend a lesser than into, how much will extend it, 2 into n times will extend it, and then we'll run one more for loop for x. I'll write for y here, for y in range. Here what is our range, m minus 1. What we'll do, append greater than, and then append lesser than, and finally append greater than. Finally, to store it, we'll join all, store it by joining, and then standard output. That's all, standard output, and that's all as a result. I'll show you guys the code once. If anyone has any doubts, you guys can ask me. I'll be showing the code. Here is the code basically. If anyone has any doubts, you can ask me, guys. Just a quick chat. One, if you have any doubts, please ask me. Okay. So I hope everyone is clear with this. We'll go to our huge grid, easy and hard version both. If anyone has any doubts till now, please put in the comment section, live chat, wherever you want, just put it there. I'll quickly solve it. Anyone chat, any doubts? Any doubts, guys? Okay, I'll just explain how to solve this both of these questions, huge grid and the huge grid hard. We have how many? 4 more questions left. Technically 3 if we take these 2 as one question. This is the easy version of the problem. Okay, fine. Task is to find minimum possible path sum. Here, given a binary sequence A of length n, we consider 10 cross n matrix B as follows. If if I is smaller than j, then B of ij is equal to sigma k is equal to I to j A of k. Otherwise, B of I comma j is equal to B of j comma I, which will just swap it. Define a path 1 comma 1 to n comma n as a sequence of pairs. P is equal to I1 j1 comma I2 j2 comma like this. It continues till I2 n minus 1 j2 n minus 1. So where I1 j1 equal to 1 comma 1, I2 n minus 1 j2 n minus 1 equal to n comma n, I of k plus 1 j of k plus 1 equal to I of k plus 1 comma j of k or I of k plus j of k plus 1 for k in range of 1 to 2 into n minus 1. The path sum is defined as sigma of I comma j, which is in P, B of I comma j. Your task is to find minimum possible path sum. Input format, first line of input contains t, all the stuff input, and then test case and n integers. Second line, binary string a of length n. Output format, minimum possible path sum. Constraints, test cases 10 per 5, n is less than 10 per 6. Both are in the range of 1 to 10 per 5 and 10 per 6 respectively. A of I is either 1 or 0. Yeah, so it's binary string basically. So yeah, sum of all test cases won't exceed 10 per 6. Yeah, fine, we'll just directly jump into the question. What is the name of this? What is this? Huge grid easy. Fine. We'll see. Huge grid and this is the easy version. I'll write easy. Done. There's our fifth question of the day. Guys, I hope everyone are clear with the question. Now guys, quickly we'll jump into this question, easy version. Okay. Just give me a minute, guys. Yeah, fine. Quickly we are going to the inclusion. We are given with binary string a of length n and build n cross n matrix B, and here there are two conditions simply. If I is smaller than or equal to j, b of I j equal to sum of a of I to j, else b of I j equal to swap b of j I. Symmetry, this is not swap, sorry, this is symmetry. We need minimum path sum, min path sum. We need min path sum. Now, key observations, I'll quickly write them. Path length equal to 2 into n minus 1, because it's a square matrix, n minus 1 rights and n minus 1 downs. Then structure of B structure, P of I comma I equal to A of I for I not equal to j, B of I comma j is prefix sum. Prefix sum between indices I and j, and then this matrix is symmetric. SYM symmetric matrix. And then next point we'll check for the trick. If any interior element A of 1, 2 up to n minus 2 is visited thrice, 3 times, in optimal path, okay, and A of 0 and the first A of 0, and last A of n minus 1 are visited twice, 2 times. Anyone in the chat, why is this like this? Anyone in the chat, guys, why? Simple. Come on, chat. This is because the path must actually pass through both the rows and the columns for one interior element, and then it will create double counting, and then only ends will appear twice, in the start and in the finish. And here there's no need of DP, we can directly count actually. So we'll directly count. We'll just make a formula. We'll simply take a formula here. If n equal to 1, answer is equal to A of 0. Else, we'll write a formula. Sum is equal to 2 into A of 0 plus 2 into A of n minus 1 plus 3 into sum of A of 1 n minus A of 0 and A of n minus 1 comes twice, rest comes thrice, done. Now quick approach, easy approach again. Approach, input, read input. After that, each test case, each TC for each test case, run a if condition, n equal to 1, result equal to A of 0, else what will we do? Else add 2 into A of 0 plus 2 into A of n minus 1, add 3 into sum of a of 1 2 up to, oh shit, sorry guys, up to n minus 2, and then print result. Simple approach if we understand the question. This is actually simple, and the hard version is actually hard. So I'll write the time complexity and all. The time complexity for this is gonna be O of n into 10 power 6, because the number of test cases. So the total time is gonna be, and but the test sum, total sum is less than or equal to 10 power 6. Therefore time complexity of this is gonna be 10 raised to 6. O of 10 raised to 6. O of 10 raised to 6. Now going to space complexity. O of n per test case. Per test case. And this is also per test case O of n. O of n per test case. Done. I'll come back to this again. I'll go to the harder version directly, and I'll give you the code of both at a time. In the harder version, what is the change? Just look for the change. The question is same. Here it will be modified a bit. What is the modification? Anyone in the chat? Anyone in the chat, guys? What is the modification? The only task here is the only change. Thus, this easy version, what will find? Minimum possible path sum. Here it is. But in the hard version, what we need to find? Number of different paths. There can be a huge number of paths, so we'll give it as modulo of a huge prime, a 9-digit prime number, which is 998, 244, 353. Everything else is completely same. Now I'll go to this huge grid hard version, 6th one. Huge grid hard version. Anyone in the chat, how we can solve this question? I'll check the chat. Anyone, how we can solve this? Anyone in the chat, guys? Fine. Quickly going over to it. Same as earlier. Same Qn, but here number of ways, and in the form of, what is the modulo number? 998, 244, 353. Mod of 998, 244, 353. Mod of this 9-digit prime number. Are you guys clear with it? Intuition and all those stuff, it'll change a little bit of it only. So I'll go through it quickly. Our intuition. What is the intuition? Anyone in the chat, guys? Anyone in the chat, what is the intuition? So I'm going to this. Yeah. So firstly, our intuition. No one in the chat is replying. Today the chat is dead completely. Dead chat, guys. Rest all are same. Here we'll use combinatrix and DP. That's all extra. Instead of brute force, we'll use DP here. Now I'll directly go to the approach. You guys, intuition is just for understanding the question. I have explained you guys the question very well in the previous itself. Now approach I'll explain, so you'll get why we have used combinatrix and what is this, DP. Everyone's favorite DSA topic, right? DP. So yeah, we'll use it here. First one, what we'll do? Well, pre-process factorials. Why we'll do this? For the feasible ranges, factorials will give the number of ways for transaction between intervals. Okay, so it is called binomial coefficients, similar to lattice points or whatever. Now we'll pre-compute factorials and modular inverses, which is, I'll take it as inverse factorial, up to which will do up to 2 into max n, since we need binomial coefficient. Now this is done. Second step. What is our second step? We'll identify the constraints we have put for once in A. Which is what we'll do here, collect the indices where a of I equal to 1, a of I equal to 1, and then these indices, this will restrict the feasible range. Feasible ranges of what? Ranges of I comma j at each diagonal step t or diagonal t, whatever it is. Next, third step, we'll construct intervals. Construct the intervals. What we'll do here, for each critical diagonal t, for each critical diagonal t, compute valid range. What is our valid range, guys? L comma R of possible row positions I. And then if a range becomes valid, range is valid, that is L greater than or R. Sorry guys, shit, I'm really sorry guys. If a range becomes invalid, what is invalid? Lower left greater than right, L greater than or R. In that case, no valid path. Return 0 basically, no valid path. Next, in our fourth step, what we'll do? Very important step, dp over diagonals. dp over diagonals. And then what we'll do here is, we'll start at, what is our starting index? 1 comma 1, which will correspond to t equal to 2. Next, what we'll do after this, we'll propagate our dp values across diagonals using our binomial coefficients. Which is basically the ways to move right or down. Now, after this, what I'll do is, I'll compress dp. Compress the dp state to only current interval, to current feasible range or interval only. Done. Now in our fifth step, final answer, at 2 for this what, at diagonal 2n, check if n comma n is valid, and then output number of ways as modulus of 9-digit prime number 998244353. Done, guys. That is the way we do this question. Anyone in the chat, what is the time and space complexity for this? Time complexity first. I'll just tell the time complexity of one test case. That's how we should actually look for. N indices, collect indices of ones. For this, how much? O of n, and then critical diagonals, build set of critical diagonals. For this, how much it will be? O of ones, which will be lesser than or equal to O of n. And then sort diagonals, this will take O of n log n, but here is a cache, small cache, but practically small. This is because this is around how much? 5, around 5 per 1. Now, after this, next step, what we will be doing? Build intervals. Building our intervals. For this, each diagonal processed once. Very easy. Then what is our time complexity here? O of n. And then dp propagation. dp propagation anyone in the chat, is it n square or O of n? I'll wait for this. Is it n square or O of n? Quick chat. O of n or O of n square? Anyone in the chat? Okay, let me see the chat. O of n or O of n square? Okay, someone has answered Okay, pro noob coder. I mean, what is this name? DP propagate. It is gonna take O of n. You are correct. At most, it is gonna take O of n. At most, it's gonna take O of n, not O of n square, guys. This is because every step is processed only once, and transitions, right, they are bounded by feasible intervals. The transitions are bounded by feasible intervals, and also each step is processed once. That is the reason why it is taking O of n. I hope you guys are clear. So with this, what is our time complexity per test case? Per test case, time complexity is equal to O of n plus, how many next is? Okay, I'll take it O of n, next one also. O of n plus O of n log n plus O of n plus O of n. Time complexity is equal to 4 into O of n plus O of n log n. So the time complexity is equal to the dominant term big O of n log n. That is all per test case. This is per test case, but for t test cases, it is gonna be O of sigma of n log n, and it's gonna be less than or equal to O of 10 raised to 6 log 10 raised to 6. And our space complexity is simply O of n, because we are creating this DP table using and also for this sorting, that before sorting the diagonals, for indices also we are taking n indices. That's all, guys. O of n. I'll quickly show you both the codes. Easy version. This is the easy version. I'll write the pseudo code if needed for both. If anyone has any doubts regarding this, you guys please put it in the comment section. I'll be answering you guys. So yeah, this is what it is. Our easy okay, I'll tell the hard version and come back to easy version. So yeah, here we are. First thing, we'll create constants and all the utilities we'll be needing, like pre-computed, and then what is this, n of okay, the combinations, number of combinations, and then modular exponentiation, yeah, and then we'll find the feasible what in the function ranju t of t comma 1 comma n. Here what we'll do, we'll find the feasible interval L comma R, and then we'll call our main function. Okay, within that function itself, we have handled all the DP propagation and all the stuff within our function, and then within our main function we have our DP propagation, we have our processing of factorial, pre-computation of factorial, and then we also have handling the special test cases, which is when it has zeros, which is basically, where is it, if not once. Here we have special case for all 0 cases, and then we have DP, what our final answer, which is here is our DP propagation stuff, and then finally our output, standard output. I'll quickly run this so that you guys don't be having any doubts that it won't run or anything. And I'll also submit it. It has got submitted already, but now you guys can see the mark here, I hope. Yeah, again, see, you can see it, it is perfect, it got submitted. So with this we complete huge grid hard. Coming back to easy version once again, here is your code. I'm gonna submit this code. Guys, my username is tower019. With that you can go to the submission history and check it. Here it is, one of the best time complexity codes, I guess this is, because as you can see the maximum time it has taken is 0.27 seconds. So I personally feel it's one of the best codes. Don't know. Oh shit, sorry. I checked some other code, guys, sorry. Well, huge grid easy, yeah, even this is one of the best codes. The max time taken is 0.08 seconds. With this we are gonna end huge grid easy version and hard version. Next is permutation cost sum. Don't know what is Codechef's obsession with giving all permutations combinations. Again, permutation cost sum, our 7th question of the day. Okay. Permutation cost sum. Okay, you are given with permutation p of length n. Assume you can perform two types of operation. Modify p of I between 1 to n to any number at cost EA, and then swap pi and pj where both I and j are not equal and are in the range 1 to n at the cost of b, and then we define function p comma a comma b as minimum cost to make permutation satisfy p of I equal to I for all I. Your task is to calculate sigma of this function, which is you have to calculate the total cost of total minimum cost of making permutation satisfy p of I equal to I. So this is, yeah, again answer might be large. Bring in our Mr. Prime 9-digit prime number. So we'll put it in the format of modulo of 998, 244, 353. A prime number, a 9-digit prime number. I'm gonna explain it quickly, guys. I'm really sorry for it, I'm tired. So I'll go to the intuition directly. Permutation is collection of cycles. Perm can be represented as collection of cycles. E.g., we'll take one example. Permutation of 2, 1, 3. Cycles will be what? 1, 2 and 3. This will be the circles. To fix cycle length, cycles. Now we'll to fix cycle length. We need swap. What we'll do? Use swaps. If we use only swaps, how many swaps we'll need? We'll need k minus 1 swaps. and cost will be k minus 1 into b. Done. Now using k modifications, use k modification, k modifications, cost is equal to, what will be our cost? Earlier it was k minus 1 into b, now it will be k into a. Now what I'll do, I'll create a hybrid strategy basically. What? Hybrid. What is hybrid? Basically mixture of both. Here what I'll do, I'll replace one element with modification. Replace one element with modification. Then what I'll do after this, I'll fix the remaining k minus 1 swap with swaps. So what will be the cost here? Cost is equal to a plus k minus 1 into b. But optimal strategy, what will it reduce into? This will reduce into, with optimal strategy, it will reduce it into minimum of k into a comma k minus 1 into b. Okay, k minus 1 into b, and again plus a comma k minus 1 into b, and then minimum of k into a comma k minus 1 into b. This is our optimal cost. So now what is my cost now? So what is my cost of cycle for cycle of length k? What will it be? K is the cost k. I'll keep it as cost k here. I don't know what I've used in the code. Cost k is equal to minimum of k a comma k or k minus 1 into b. Done. Therefore our function for f of p comma a comma b is equal to sigma cycle of length k minimum of k a comma k minus 1 into b. That's simple, but here we have a very big challenge, which is we can't directly compute. We need to evaluate sigma of a is equal to 1 to n, sigma of b is equal to 1 to n for function p of a f of function of p comma a comma b, which will lead to the time complexity. What will be its time complexity in that case, guys? Two loops will run, one from a is equal to 1 to n, second one from b is equal to 1 to n. This will go for the time complexity of, if I take this thing like this, sigma a is equal to 1 to n, sigma b is equal to 1 to n for the function p of a comma b. This is our task here, challenge. I'll write it as challenge. Main challenge we have in this question is this. or else it's a very easy question if O of n square is allowed. Now in this case my time complexity will go to O of n square. Is it possible when n, is it possible for n smaller than or equal to 2 into 10 power 5? No, it will definitely give TLE, 100% TLE. Don't even try this, not try at home. So yeah, impossible. So what I'll do now, I'll decompose permutation into cycles. Decompose permutation into cycles, and then for each cycle cost, compute cost. We have a formula. Earlier I won't write that big of a formula. Compute cost. Here a math trick will come, which is partition of a comma b in grid will be k of a lesser than or equal to k of k minus 1 of b, or k minus 1 of b is smaller than k of a. After this what I'll do, I'll compute sums of integers and squares, and then after that simply we'll use helpers like S range and SQ range. One is for sum range and one more is for square range, sum of squares in the given range. So now what will this do? Instead of instead of brute force prefix formulas, we'll use prefix formulas. This is in the next step, not in the same step. Prefix formulas which will bring the time complexity to O of 1. So yeah, now I'll quickly go to my approach which I used. Approach, yeah, cycle decomposition, which will take O of n time complexity. I'll write it just simply. Cycle decomposition of permutation. Okay, of permutation, so you guys don't get confused. Second step, count how many cycles. Count of length k exist, and then finally cost. For each cycle k, compute, what should we compute? Sigma a is equal to 1 to n, sigma b is equal to 1 to n, minimum of ka comma k minus 1 into b. After the step, what I'll do in the fourth step of approach, multiply contribution. I'll multiply the contribution by number of such cycles. And fifth step and the final step, accumulate spellings. Accumulate final and as modulo 998, 244, 353. Okay, so I'll quickly even do TC and SC, time complexity and space complexity again. Time complexity, cycle decomposition, cycle decompose O of n, and then summation of each cycle, summation of each cycle length k O of n by k. This will be O of n by k. I just wrote it in the next line. So total overall cycles, this will be O of n log n. So our final time complexity is equal to O of n log n, perfect for 10 power 5. N is lesser than 2 into 10 power 5 test cases. And now coming to space complexity for storing permutation, store permutation O of n, after that cycle counts, again O of n, and then visitation array, again O of n, leading to total time space complexity of O of n. Yeah, and our total time complexity is equal to O of n log n. Equal to, done. With this, I'll quickly go to the code. Sorry, permutation cost. First one, I have created a function Ranjan a comma b with my own name, which is for modular addition, and then Rancho, which is for modular subtraction. Next Ranju, which is for modular multiplication, and then S range and SQ range. I already told why they are used. SQ range, sorry, first S range, it is for sum of numbers L plus 1 up to R modulo mod. We'll take it in modulo mod. Mod is a number which is, we already know, 998 244. Does that 998 244? Huh? Where is it, man? Yeah, 998 244 353. This is our number. And then SQ range is sum of squares in the range of L comma R. And then CNTK, which is over, where is it? Here. This is for number of cycles. And then inner loops, will be using inner loops for partition with minimum expression changes. And finally we'll have our answer, which is answer Ranjan of answer comma Ranju of, okay, we'll call all the functions and we'll just do modulus of it. Finally we have to give the answer as answer modulo 998 244 300 and what is it, I forgot, 353. So yeah, this is my answer. I already submitted it by mistake. Again I'm submitting it. So you can see one of the best codes written. One last point about this question, guys. What is the fun part in this question? If we use brute force, we'll see how math is used for CP, like how CP and math coexists, and without one way, like without math we can't actually do CP. We can see it clearly in this question, like a clear cut example of the math power. With brute force, the time complexity of this is gonna be O of anyone, O of n cube, and we are reducing it to what? Not O of n square, not O of n square log n. We are reducing it to O of n log n. This is brute force. This is number theory. Number theory. So this is how it was done. Again, as I said, math is very important for CP, but especially the permutations and the combinations. Oh man, one of the most important things. Now, final question of the day. Delete maximum. 8th question. Talking from 2 hours continuously. Yeah. How much time since I started the stream? Almost, yeah, see guys, you can see 1 hour 58 minutes. Delete the delete maximum. I'll read the question. It's basically array question, a simple question, not much to worry. Yeah, you are given with an array A of n distinct elements satisfying A of I is in between 1 and n. Consider performing the operation as many times as you want on A while A is greater than, okay, there's modulus of A, sorry, mod of A. Let's, okay, it's mod of A. One second, I'll just drink water. So here we are calling it as a modulus function. I'm back. A is greater than 1. Choose, what is that operation? Choose a continuous subarray of size A minus 1, then delete the maximum element of the subarray from the original array. Note that maximum element is unique due to elements being distinct, and that this decreases the size of A by 1 each operation. Find the number of arrays that can be formed from the above process. Again modulo of that number, yeah. Again modulo of 998, 244, 353. Input format, you guys read it all, and then output format, final new line, number of arrays that can be formed with operations modulo xyz 998, 244, 353. Test cases 10 power 4, and n is n is in between 2 and 2 into 10 power 5, so we can't go for n square. It should be in log n max, in log n I mean. It can't be in n square. We have to bring it to n O of n or O of n log n. So I hope you are clear with the question. I'll quickly go to the inclusion. What is the name? Delete maximum. So final question of the day. Delete maximum. What is it? Here okay, so quickly going on, what is the inclusion? Chalo, inclusion. we are given with we are given with array A of length n, size n, distinct integer, distinct integers from 1 to n. Done. We pick a subarray. Pick, what we'll do here is pick subarray. I won't say the definition of subarray, you guys can check it every stream. Of size mod of a minus 1, and then we remove this first step, and this is in our next what, remove max element of that subarray. From original array. Done. Now what we should do, we have to find distinct arrays. We have to find number of distinct arrays that can be formed after performing operations until only one element remains. So this is our intuition. We'll go to our key observations. What are the main observations? First one, max element property. We'll take it as max element property, which is, since elements are in like elements are from 1 to n, first n will get deleted, n first deleted, then n minus 1, and then n minus 2, like this it will go. So deletion order is strictly decreasing. Nowhere there will be two elements because it's a complete unique element set. And then second one is we'll take a range expansion from left to right. Okay, so in this range expansion, what we'll do, we'll track position of elements, elements starting from 1, which is the smallest, and then initially only one is inside our range L comma R, and then for each m is equal to 2 to n, n look at its position at its posi, which will be, what will be its position if position of m is outside range L comma R, then when expanding range, we gain m ways. This is because, why is this all smaller numbers in different valid subarrays. Done. Next, if position of m is inside current range, we get only one way. And we won't have any new choices or new ways to do. And this is gonna build our total number of arrays. Now, quickly going to the approach. I'm sorry guys, I'm really sorry. Quickly going to the approach. First thing, I'll simplify the approach. I'll explain it quickly so that you guys can understand, and also, yeah. First, what we'll do, we'll pre-compute. What will I pre-compute? Position of x equal to index of element x in array. Second step, what I'll do, I'll initialize. What will I initialize? First, L equal to R equal to position of 1, smallest element. This is smallest element position. After this, next one, answer is equal to 1. We'll initialize both of them. Next, in our third step, what I'll do is, for m from 2 to n, if position of m is lesser than if the position of m is lesser than L or smaller than R, greater than R, then what I'll do, I'll expand the range. which basically means not in range of L comma R. Expand range, and what we'll do here, what I'll do here, answer, increment answer, answer plus equal to M. Answer is equal to answer plus M basically. Then else what is my answer if not this? Answer plus equal to 1, increment by 1, because only one new way is there. After this, finally what we'll do, you will update L R, we'll update L and R to include position of M and finally in our final step what I'll do is I'll give the answer is equal to answer is equal to answer mod or I'll simplify it, I'll make it better. What is it? Total arrays is what we need, count of arrays. So yeah, number of arrays formed, array formed, what I'll do for this, equal to answer mod of 998, 244 or 224, 998, 244, 353, 244, 353, 998, 244, 353. I'll simply write it as answer equal to answer modulo mod, where mod equal to 998, 244, 353. This is a 9-digit prime number. Now, before going to our code, I'll give you guys the time complexity and space complexity. The time complexity first. Now, each test cases is pre-processing array once. So, pre-processing of an array O of n, pre-process array, and then O of n for looping. Okay, so what is my total time complexity? My total time complexity per test case, time complexity per test case is equal to O of n, and for 10 per 5 cases, what is it? 2 into 10 per 5, right? Okay, so for given test cases, so the given test cases, it's gonna be TC is equal to O of sigma n. Sigma is from 1 to t. 1 to t. Sigma is from 1 to t. Sigma of n. And now, quickly space complexity. Okay, shit. Space complexity. First one, array A and position A, and 2 arrays we are taking, and size of them is O of n. N elements, so the size of them is O of n. And then there's the only thing, rest all are some variables which we are taking. So the space complexity is equal to O of n, order of n. So this is a optimal solution which we have got. I'll quickly go to the code and I'll explain you guys the code. Yeah, here is my code which I wrote, which is I'll take fast input using system, importing sys, and then we'll take number of test cases and all this for test cases, and then input size n. That has done the next line itself. Then we'll initialize the arrays, which is initializing the arrays. A is equal to 0 into n plus 1. Position is equal to 0 into n plus 1. This is our array initializing arrays. Then we'll read the positions for I in range 1 to n plus 1. Sorry, yeah. For I in range 1 to n plus 1, the first for loop, this one. I'll make it full screen. This one, where the cursor is currently, for this is for reading the positions, and after that answer is equal to 0. From there again we'll initialize it, and after that we'll run the second for loop, which is for m in range 2 comma n plus 1. This for loop is used for processing the values from 2 to n, and then we'll expand the range, which is if p smaller than l or p greater than r. This is expanding the range, and if within that range, what we have to do, we have to add 1, because the only possible way is 1, and then storing for a final answer, output lines dot append, and then printing all the results, sys.out.write. Again, main closing, name is equal to main, and call the function. I'll submit the code, guys. Array, yeah, so you guys can see it works perfectly, all good, and maybe even this is one of the fastest codes written, I hope. So this is how it is done, and with this we are gonna end today's live stream. Before that, let me check what is my rating today, how much did it increase to. So it reached a rating of 2311. So I'm really happy with it. I started the contest almost an hour late. With this, we are officially ending our stream. Thank you everyone who joined. Please like, share and subscribe to my YouTube channel. And we'll meet in the next live stream, which will be very soon. Until then, have a good time and good night, guys. Thank you. Like, share and subscribe to the YouTube channel one last time. And I'm ending the stream.